Any questions over the homework? Any questions over the homework assignment? We're good with the homework assignment? Okay. What we're doing today is determinants, and we'll get to Cramer's rule tomorrow, but we'll talk about determinants today. Now, when we talk about a determinant of a matrix, there's two things. Well, one main thing is that the matrix itself has to be square. For us to be able to take a determinant, it has to be a square matrix. So the number of rows and number of columns have to be the same for us to be able to take the determinant. Now here we're talking about a second order determinant is the difference of the products of the two diagonals. So when we talk about second order, we're talking about a 2 by 2. So it would have 2 rows and 2 columns is the second order. And what it's saying is, so we're going to take the product of the difference of the product of the diagonals. So A times D minus B times C. Difference of the product of the diagonals. So here, 4 times 6 minus 5 times negative 3. And that's going to give us our determinant. So if we look at the first one here, we're going to take the determinant of these two here. Now, there's 2 ways that we can determine if we're wanting to take the determinant. One of them is that it's going to use the abbreviation DET. DET is determinant. Or instead of having actual brackets or braces, we have absolute value kind of symbols. Because when we normally write a matrix, we normally write it as this here. So when we have it as more absolute values, we're talking about determinants. So here we're wanting to take the determinant of this first matrix here. So the first thing we're going to do is multiply these two here. So we'll have 5 times 9 minus, going the other way, negative 4 times 8. So we're going to take all the diagonals going from the left to the right and subtract from it all the diagonals going from the right to the left. Well, 5 times 9 is 45. Minus, well, negative 4 times 8 is 32. Well, the negative and negative make a plus, which is, so the determinant of this matrix is 77. Now we can do these in the calculator. The graphing calculator will do these for us. But I don't see that this is as big of a time saver or as nice with 2 by 2s. Because for us to plug this in, well, throw that out. We'll need to go second matrix over to edit. So 2 by 2. And the one we just plugged in was 5, negative 4, 8, and 9. So we'll have to plug the matrix in. So we good with this so far? Now second matrix. So we'll go over to math. And we need to find the function for determinant. It's kind of nice. This determinant is first one on the list. Because DET is short for determinant. So we can hit enter, second matrix, call up the matrix we plugged it in as, hit enter, and it'll tell us that it is 77. For the 2 by 2s, doing it by hand or doing it in the calculator, it's almost faster to do it by hand because we're just multiplying the 2, subtracting the other 2, multiply together, and that's our answer. So if we look at the next one here, if we do this by hand, well, we'll have 0 times 11 minus 4 times 6. So we'll have 0 times 11 minus 4 times 6. Well, 0 times 11 is 0. 4 times 6 is, so really this is negative 24. So really with 2 by 2s, it's almost as fast to do it by hand as it is to type it in, to go and do second matrix, plug the matrix in, then get the determinant of that matrix, and be done. Questions on this here? Hopefully these aren't too bad. Because if we look at the next two here, I'm not going to worry too much about plugging these in because really we're doing negative 6 times 8 minus negative 7 times 10. Well, negative 6 times 8 is negative 48 minus, well, negative 7 times 10 is negative 70. Well, here the negative and negative make a, which gives us 32. So again, I think it's almost as fast to just do this by hand. And the last one, we'll have 7 times negative 4 minus 5 times 9. And at this point, if you wanted to just type this in as we have it, hit enter, and it would give you the answer. 7 times negative 4 is negative 28. 5 times 9 is 45. 5, 6, 7, 8. Here the 1, 5, negative 73. 22? Yes. Thank you. No. Yeah, no, because 2 would get us to 50, and then another 2 would get us to 70. Yes, thank you. Questions on these here? We like these second order determinants. Well, if we have a second order, we can also have a third order. 3 by 3. Now, we have the steps here. I have these written out for you. Because again, we're doing the same type process. We're going to take all the products of the diagonals going from the left to right, and we'll add those together and subtract it from all the diagonals going from the right to the left. Kind of like what we just did. Now with a 3 by 3, we have more than one diagonal. That's possible. Now, I'm going to put a highlighter, use highlighters to show this here, because we can see this diagonal here, yes? Going right to left. Well, we also have this diagonal, and we also have this one here for all the ones going from the right to the left. Now, we don't have to color this in like this because it's a little bit hard to see this way. But what we can do instead is 4, 3. I'm going to rewrite it back out, and it'll be good to rewrite it back out. This here. Now, the first main step that we're going to do to help us see these diagonals is to rewrite the first 2 columns again. I rewrite them back out. And the reason that we do this is to help us to see those diagonals. Because the first diagonal, going from the left to the right, was kind of easy to see, 4, 2, 9. So that's one of our first diagonals, and I'll write all the diagonals going from left to right in green. So we have 4 times 2 times 9. Now the next one I did was negative 8, 6, and negative 4. Because it wrapped back around the first time I did that, yes? But if we look at it now, well, I'll go on and get a yellow highlighter for this. Because this was the first one we pulled out. Well, the next one, instead of wrapping back around, it's straight right there. So that's what the positive or value, we rewrite those first 2 back out. Because now instead of it re-wrapping back around in that 1, it comes back out. So negative 8, 6, and negative 4. And our last diagonal is this here. Not too far down. Which is our 3. Negative 3 and 5. Questions on this so far? Now we could do the product of each one of these here and see what we get. So 4 times 2 times 9. 4 times 2 is 8, and 8 times 9 is 72. Negative 8 times 6 times negative 4. Well, the two negatives will make a positive. 8 times 6 is 48. And 48 times 2 is 182. 192. Negative, yeah. Negative 8 times 4 times, what was it, negative 8, 4, 6. Yep. I switched the negative 4, 6 and negative 4s. But it gave us the same value. Because I knew we had two negatives, 8, 4, and 6. And the last one, 3, negative 3, and 5. And we add these three together. Because like with the 2, the one that we started with, are going from left to right, we had a single number. We'll still have a single number, but it's all three of these diagonals added together. Questions on this so far? 72, 92, negative 45. Well, 72 plus 192 minus 45 is 219. We good with this so far? Yes. Now we have to have the diagonals go in the other direction. No. Because we have the ones going from the left to the right minus the ones going from the right to the left. And we'll repeat this process. So we'll have negative 8 times negative 3 times 9 for our first diagonal. Then we'll have 4 times 6 times 5. And our last one is going to be 3 times 2 times negative 4. And with a 3 by 3, we'll have 3 diagonals going in each direction. Eight, 3, and 9. 8 times 3 times 9. 216. Now, if you notice, I didn't type the negatives in because we have two negatives, so the final number should be positive. 8, 3, and 9. We get this here. 4, 6, and 5 is 120. And then we have 3, 2, and negative 4, negative 24. And again, we add these three together. 312. Any questions on this point here? Now we subtract them. The ones going from the left to the right minus the ones going from the right to the left. 319 minus 312 because 93. And it would be negative. Negative 93. Questions on this here? Let's do this one again. But this time, Let's do it in the calculator. So in the calculator, if I want to do this here, well, the first thing I need to do is plug the matrix in. So this matrix here is a 3 by 3. 3 rows, 3 columns. And our numbers are 4, -8, 3. -3, 2, 6, -4, 5, 9. So we're good with typing that in, yes? Once we finish typing it in, we'll hit second quit. Then we can go second matrix, over to math, and hit enter to pull up the determinant. And we input it in as matrix A, so we can go second matrix A, hit enter, we get -93. Yeah. Yes. With the 3 by 3, it is a lot easier to type it in. The 2 by 2, it's almost just as fast to actually solve it by hand as it is to plug it in. Questions on this here? Not too bad once we typed it in. So we get the exact same thing. Now, let's do 2a in the calculator, because I'll show you this here. So we do need to change the matrix. So we can go over into edit for this here. 2a is still a 3 by 3, but this time it's -5, 9, 4, -2, -1, 5, -4, 6, 2. And I have a feeling you're getting faster and faster at typing these in. Then we can go second quit. Now, again, I showed you again going second matrix over to math to get determinant. I always plug it back into the same matrix, unless I'm trying to add two things together or use more than one matrix at the same time. I normally put it into matrix A. If we notice above, I already have determinant of A, yes? If I go up, press the up arrow to highlight it and hit enter, it brings it down, yes? Have I redefined what A is? So will this calculation be the same as -93? I mean, there's a small percentage, but we can recall it. And when I said small percentage, it just means that if we worked it out and the numbers worked out to have the same setup that it gave us -93, then it is possible, but it's not likely. But we can do that. So I could change for the next one. I could change what matrix A is, go up, highlight it, hit enter, bring it back down, and it'd give me the next one. Questions on this here? And that's it. Now, it's not 2 through 12, mainly because, well, yeah, it's not 2 through 12, it's 1 through 12. So you have a worksheet I'm going to hand you all. So you're just doing the whole worksheet. Actually, I'll give you all one extra copy. Four.